A monochromatic light of wavelength lambda in air incident normally on the thin liquid film refractive index n that is suspended in air. The rays are shown at an angle to the normal for clarity. So these rays should be like in this direction. They go to the right, then reflects back like that. But we can't draw it like that. It won't be clear for you. So they draw it with an angle. So the angle on this value is all clear. This diagram is all clear. What is the minimum thickness? The D. We need to find the thickness of the film layer so that the reflected light ray undergoes constructive interference. So this is simply a thin film interference. That's the HL of the waves. Topic 9. Let's go to the data book. Let's see which equation are we going to use. You'll find that the constructive interference for a thin film will be 2dn equals to m plus half multiplied wavelength. So the minimum thickness means we need to have m as 0. Because the minimum thickness, it means that I need to have here just a half path difference between the two rays. Like if you have this is as a wave, we need to just have half of the wave. So this will be 0 plus half. This is the minimum. It's like the center interference, the central spot in the interference sequence. We give it the order of 0. So the minimum thickness of the thin film means that we can substitute the m here by 0. That means that I need a path difference with half lambda, 1.5 lambda, 2.5 lambda. But the minimum one is half lambda, which is m equals 0, the order of 0. So let's do the math here. 2dn equals half times lambda. To find the thickness d, it will be half lambda over the 2, and the n will go to the other side, or we can divide both sides by 2, and simplifying it will be lambda over 4n. That gives you the d. So the correct answer here will be number